Hello all, good evening. So share this link with all your friends. We are going to just start in few minutes.
Hi, hello, a very warm and very good evening to one and all. Myself, Vishal, I would like to welcome you all on this webinar on black hole conducted by none other than our astronomy scholar, Mr. Soham Deshpande. Uh, Soham,
Hello all, yes, I'm here.
yeah, Soham, I would like to request you to start the really interesting and a wonderful webinar on black hole. Soham, over to you.
For sure. Thank you. Hello all, good evening. So in the last seminar, we all had a great discussion and a great time discussing what astronomy is all about, and we had three topics by then. We discussed on future of Indian astronomy. We discussed on dark matter, and we also discussed on cosmology. We had a basic overview that what cosmology is all about, and now we after that particular session we actually had a quick poll, and you all voted for black holes, which is your favorite topic. So according to the majority, we are going to have a webinar on black holes now. I hope you will like it, and whenever we send the polls or whenever we send the Google form, you all had a great response in that, and I'm really biggered by that particular response. So please keep supporting us. That is a very big motivation for us. So yeah, now I'm sharing the screen. Vishal sir, please let me know what is exactly the overview here, and I will share the screen in just few minutes. Okay, I hope the screen is visible now.
Just a minute, Soham. Yeah.
Yes,
Yeah.
this is Sidhu.
Okay, thank you very much. So first of all, I would like to tell you all that this is an interactive session again, okay? And I have added some two bits of quizzes as well in between. I'll tell you that what is exactly going to be like, and yeah. So today's topic is supermassive black holes, a very big topic, a very cherishing topic, very enthusiastic topic, the topic which everyone likes, and that is how we all got interested in astronomy and cosmology. So this is our topic for today on your special demand. I am Soham Deshpande here. I'm from Maharashtra, and yes, I am going to take this session today. So basic overview, I'll tell you the index basically. What are we going to discuss today, or how we are going to tackle this particular topic? Okay, so we will have a basic introduction on black holes and discussions on black holes, like how black holes were formed. What are the some of the very interesting theoretical theorems or very basic things which are there in theoretical physics and quantum mechanics. Then practical proofs of black hole, that how exactly we discovered that in which galaxy what type of black hole is there, and how did we take out the photo of the black hole, which was as good as taking a Nobel Prize. And in between we'll have a small quiz and discussions as well. So yes, keep your energy charged, and at the end of the session we'll send a form link. You have to fill it, and according to that you will get your certificates as well, and you can for sure use those certificate in your resume, or even put it on LinkedIn and flash those certificates in front of your friends. So yes, now let's start, shall we? Vishal sir, I hope the screen is fine. Should I start?
Yeah, the screen is visible. Can anyone
Okay,
from the
great.
participants confirm? Can anyone?
Yes.
Yeah.
Okay, great. Okay, so yeah, let's start. I'll try my best to give you the all the knowledge which is present there, and let's start. So let's start from the very basic to basic. Baby steps will start from the definition. I'll try to keep it as interesting as possible, as in a story format as possible, in a very short manner. I'll try to explain so that you can keep up interest. If I go into very much deep, there is a very big possibility that you will tackle some very interesting quantum mechanical problems which might go bounce your head particular definition on that particular line. So what they are trying to say is that one point in space fabric time, you can imagine that on a sheet of rubber, one point of one point where the depth of the point, where the depth of the space fabric time, that fabric, it is going to bend at a very infinite level. And in that particular, if you imagine that on a rubber scale, then you can imagine that it will be going at very much depth, and it will be bending that rubber sheet at an exceeding level. So if you try to simulate that particular scenario on the real practical aspect of space, you can imagine that the space fabric time gets bent by the infinite gravity which is already there, which is possessed by the black hole. And because of that, it is having a so much it is having so much of infinite density that even light, which is the fastest speed, it is having the fastest speed, known speed in the universe, which we say that nothing can be more speedful, or nothing can be more as fast as light. That particular thing, that particular light, or that particular phenomena doesn't get out of the black hole because it is having a point of infinite density. So that is how you can relate with the black hole phenomena. And it also matters a lot that what is the exact size of the black hole. We'll discuss it in the next slides, that what is exactly how to determine and what are the types of black holes in the next slides. So yeah, let's go ahead in the next further few topics. Okay, so now we are on to the topic where that what are the types of black holes. You can just now I tried to explain you that how the space fabric time is imagined. So you can just see that the space fabric time in the picture, it is just try to holocast the exact phenomena which I was trying to say. Now let's get back to the topic, that what are the types of black holes. Now that is normal size black hole, microscopic, which is primordial, like primordial is the most smallest type of black hole. Remember, I am saying small, but it doesn't mean that the mass of the black hole is compromised. Okay, even a spoonful of a black hole matter can also be as heavy as billions of tons. and it can be as more it can have more mass than the normal Earth as well. So have this particular fact in mind. Now next two points are supermassive black hole. These particular type of black holes, the Sagittarius A star, which is there in the center of the galaxy, center of the Milky Way galaxy, it is also having millions of solar masses of the black hole. Now, what do you mean by exact solar masses? It is just a unit to describe the mass and the size of the particular celestial body. Okay, in the last session, I did explain that how solar masses function. I will just give you a more overview, or I will just revise the concept that how solar masses can be tackled. Now, one sun mass, the mass of our sun is called as one solar mass. Okay, any body, any sun or any celestial body which is having more mass or less mass than that particular celestial body which is our sun, it will be compared with the solar mass. It will be compared with that particular unit. Okay, so for example, if I say that one celestial body, if one particular planet is having 10 solar masses of the mass, means it is having a mass of 10 suns. Okay, so you can imagine that how it is functioning. Okay, now estimation 3 million solar masses of Milky Way galaxy. Now our Milky Way galaxy black hole which is there, it is having a mass of 3 million solar masses. Means 3 million suns, means 30 lakh suns can fit into that particular black hole, or it is having the mass of that particular area, right? So now you do have a basic overview that what is exactly the definition of a black hole and what are the types of black holes, right? So let's move on to the next slide. So now let's get back to our topic of Einstein. Whenever I talk about theoretical physics or theoretical quantum mechanics or something, it always comes to one particular theory, which is general theory of relativity, or it might go to special theory of relativity afterwards. But that is not the point for today. So let's concentrate on this. So general theory of relativity, basically it just says that gravity wraps space time. The point, or for example, if there is one point which is having infinite gravity, okay, just take out the name of black hole for now. One point is there which is having infinite gravity in it, right? So it will bend the space time at such a horrible level that you will find that it might cover, or it might form a portal between one point of the universe to the other point of universe. And this is all theoretical. Okay, but this might happen because we have mathematically proven that yes, it does happen, but it is not a proof that it connects, or it is forming a canal or a duct between 2 points. But it is just a theory. So it is just a theory which I have added to make it more interesting. Okay, so that particular duct is called as name wormhole. Okay, so that universe, for example, in our universe near Earth, if one black hole is getting formed, right? So it will be having so much of extreme gravity that it will bend the space time at such a horrible level that it will connect after one particular point. It will connect one space time position to the other one. Okay, and you can just see the picture what I'm trying to say, and you can imagine it very well. This picture is already very famous, so I hope you all have seen it already. Now you can, as I said in the starting of the session, that you can imagine it with a rubber sheet analog, right? So for example, you have also seen this experiment that one ball, I will keep that on rubber sheet, right, and it will be having more mass. One small other ball which will be having lesser mass than the bigger one, and if I try to round it off, if I try to send it in an orbital manner or in a circular manner, after 2 or 3 circles, it will its orbit will change and it will go towards the center where the more mass is there. So now my question is to you people, that if you imagine that in a very good way, that sun is there, it is placed, for example, it is between the solar system, it is the center of the solar system, right? So if you put one sun between on the rubber sheet and it bends the space time a bit, and you will take one more small marble or a small ball, glass ball, and you will try to keep it a bit away from the center. First of all, it will go in a bit elliptical manner, and then it will go to the center. So imagine that ball is sun. Sorry, that orbiting ball is Earth, right? So it is orbiting around sun now. So after first or 2 to 3 orbits, it will round perfectly. After that, it will lean towards the center. Then after that, it will touch the center and it will go inside it, or it will collide with that. So why isn't the Earth also going inside the sun, or why isn't the Earth is also colliding or going towards the center of the solar system? So my question is that to you. Can anybody answer? Anyone having any idea that what I just asked? Okay, did you understand the question? Am I audible?
Yeah,
Yes.
Okay. So, what do you exactly got from my question? What do you exactly want to say? Even if you repeat my question, it is fine because I will get a basic overview that yes, you got what I want to say or what I want to ask.
yes, guys. Like if you're wrong, also if you're right, also no issues. Like say what you know. Like we are here to share the knowledge, and Soham will guide you. Anyone? Like if you are uncomfortable to unmute the mic, you can type in the chat box also, no issues.
Okay. So I'll answer this question in the last of the session. Okay. If you have, if you anybody wants to say, you can just cross me at the in between itself. Okay, no worries. Okay. Let's move forward. Forward, we have a very interesting thing which I want you to perfectly take part in it. A small quiz, of course. If you are going to take part in astronomy sessions, especially if I am taking the session, speciality in it. Okay. Name the mountain and on the planet it is located on. Yeah, someone is
Is it a
typing.
volcano which is located on Mars?
Yes, and okay, someone I think have named it as well in the chat box. Yes, it's true. Ritu Yadav. Yes, it's Olympus Mons. It's situated on Mars. Yes, it is the most tallest mountain range in the whole solar system. Okay, so it is bigger than the Everest as well. You can compare. I have added one figure, one small diagram, comparison of Olympus Mons and Everest. You can see that from the space how the Olympus Mons look from the space. So Olympus Mons, what is its height? It is having a height of 21 kilometers or 22,000 feet. What is the height of Everest? It is 8.8 kilometers, approx 9. To be honest, to be precise, 8.8 kilometers. And you can compare it that how big or how huge Olympus Mons is. Now it used to be an active volcano, but now it is a dormant one, or to be honest, many scientists say it is extinct. So yeah, that is how it goes. And let's now. I am really glad you all answered. Now let's go to the second question. So don't Google. Okay, this is the challenge for you. Don't Google. And what is the color of the sun, guys? What is the color of the sun?
Sun
Anyone?
emits photons in all wavelengths. So technically, sun doesn't happen.
Okay, I think Ridhima Teli answered white. So yes, actually Sanjay, your answer is partially correct. Actually, to be honest, the thing is that if you look at sun with different wavelengths, you will find different colors. You can see that I have added a picture there. In infrared, in X-ray, in gamma rays, in ultraviolet and all. So you can see that it is having a different colors. But to be honest, if you see, sometimes you just look at sun and during a very sunny day, 1 p.m. In the afternoon, if you look at sun directly, and if you just make your angle a bit inclined, you can see that there are some rainbow type of crystals in the air which are formed because of the light only. So basically, sun is having every color, and you do know that you have studied in your inferior classes that if every color is there, like Vibgyor color is there, then it will at last form the white color. So yes, white is the correct answer, and You can imagine this from the experiment of the prism, which we all have did in 8th, ninth, and 10th experiment, 10th standard, right? So yes, the answer of this question is white. Okay, next. So this is a bit theoretical part. I have deliberately added this part because you should know a bit more into depth, and don't get afraid of these type of things. This is just normal physics. I'm not going in depth of this. I'm not going to take numericals or something. Okay, so don't get afraid of this. Even I am afraid of physics, classical physics and all. So this is just theoretical physics and just conceptual thing which you should know. Okay, now escape velocity, density, and Schwarzschild radius. This is something new term which you are learning. I think. Do anyone know what Schwarzschild radius is? You can just raise the hand. I will not ask question. I just want to see how many people know. How many people know about the Schwarzschild radius? Just raise the hand. Okay, Sarvesh knows. Anyone else? No one. Ritu knows. Okay, great. So 2 or 3 people knows. Great. Okay, so let's get back to the topic. I just wanted a brief overview that how many of you know. Okay, so now let's revise. For those people who know, let's revise. For those people who don't know, let's start from the scratch. No worries, we have whole time in the universe. Okay, so for example, if you are having a rocket, right, and for example, it's GSLV. Now, if it's going, you have launched, okay, you have launched. Stages of separation are there. If you all know, there are stages of separation. Step by step, stage 1, stage 2, and stage 3. Mostly, there are also stage 4 rockets. So, step by step, it segregate and it leaves fuel tanks. Then it discards its main body. Then it discards its supporting fuel, and then the main payload which is there, it is launched in space. Okay. Now, when this particular process happens, this particular rocket leaves the influence of the gravity of the Earth. It should be having, must be having actually, not should, it must be having more velocity than 9.8 meter per second square. Because it is the gravitational power accelerated or exerted by the Earth. Okay, so you need to have more acceleration than 9.8 on the basic level. Then only you will be able to leave the gravitational influence of Earth. Okay, this is escape velocity. Now it depends. It is varying from planet to planet, from body to body, from asteroid to asteroid. It is varying because on the mass and on the on the atmospheric turbulence which is exerted by the Earth, it varies. Because, for example, if you are having 100 kgs on Earth, you all might have known this fact. If you are having a 100 kg weight on Earth, then you are only having 16.6 kgs weight on Moon. Okay, so the gravity or the gravitational influence is very different, because that Moon is having 1/6 gravity than the Earth. Okay, it is like the 1/6 part of Earth. That is why on Mars it is around, I think, 23 or 26 kgs. On Jupiter, I think it is having 126 kgs or something. So Jupiter is having more gravity than the Earth. So this 9.8 which I am saying, this will be around 10.5 or more than that, or around that particular approximate ratio. This number will be varying from celestial body to celestial body, right? You got this term. Now let's get back to the point where I want to, density. You all know, right? So I have explained that in the previous slides that density, it is something which is black hole is having a lot in in its own vicinity. Now let's get back to the new topic. It is Schwarzschild radius. Now, Schwarzschild was a very big scientist of his own time, a theoretical scientist. He has collaborated works with many big scientists. For example, Mr. Schrödinger, and even I think Einstein also is having some papers. Okay, so now Schwarzschild radius, which you can see here, RSCH. Now this is radius Schwarz. R Schwarz is equal to 2gm upon c square. This is just a normal formula. Okay, now 2 gravitational constant multiplied by mass upon speed of light square. Okay, now this is the formula. Now what is exactly meant by Schwarzschild radius, guys? Now Schwarzschild radius, for example, let me try to explain you in a bigger manner. For example, you take sun. Okay, we have a star. You have a star, it is our sun. Now if you want to change our sun into a black hole instantaneously at this moment, at this second, then what you need to do? You need to exert a lot of pressure on that particular body, right? For example, if you want to for there is a tin box. Now you want to make that tin box converted into a tin metal or a tin strip. So what you will take a hammer and you will start hammering that particular tin box, right? After one particular point, it will be ductile. It will be converted into a small tin wire, whatever you want it, right? Or a tin strip, right? So that particular sun, which we are talking about, if you exert a lot of pressure, extreme lot of pressure, and if somehow you take that sun, which is like a lot bigger than the earth, so that I think that millions of suns can be millions of earth can be can be fitted inside one sun. So if you convert that sun and if you make it smaller, and at one point if you make it so small that its radius is around 3 inches, approx 3 inches, then it will suddenly convert into black hole. So that 3 inches which I'm talking about, 3 inches is the Schwarzschild radius of the sun. Okay. Now, what should be the definition of the Schwarzschild radius? Schwarzschild radius. It is a radius of a particular body that after exerting so much pressure on the body, it will directly convert from its original form to the black hole. It's called a Schwarzschild radius. Okay. I hope you have got it. Give me one thumbs up if you have got it. If you have got the topic, give me a thumbs up or hand raise, please. Great. Okay, good response. Love it. Okay, now, so this is particular Schwarzschild radius is. Now, how you can calculate this? Just put the values. The mass which you are talking about, 2 gm, right? The mass is there, the m is there, right? So you can just put, for example, just put there 100 kgs. Okay, gravity is a constant. Light is also constant. 3 to 10 to the power 8, right? 2 into gravitational constant upon light constant multiplied by your mass, for example, 100 kgs. Now take the value out in calculator. You will get the Schwarzschild radius of this. Now what should be the Schwarzschild radius of Earth? I think the Earth's mass is around something. No, the radius of the Earth is around 6,400 kilometers, I think. Right. So if you convert, if the Schwarzschild radius, if you convert the mass, and if you calculate this, the Schwarzschild radius of Earth will come around 0.88 centimeters. So if you like, that means that such a big Earth this is, you need to convert that particular Earth in 0.88 centimeters. Just you're having a 15 centimeter scale. Just imagine how small that number is. So you can imagine from this particular ratio that how dense, or how, that means whole Earth in just 0.88 centimeters. Whole Earth. I mean, even you are having a height of, for example, if your average height is around 6 feet, then you will be just 0. Some nano mm or something you are having contributing in the Earth. So just imagine that how dense the black hole is, right? So you can imagine from that. Now, I hope you all have got what I tried to say from the Schwarzschild radius. I hope you have learned something new today, and the people who knew have got something, have revised that particular concept very well. Okay. So the last point, you can underline that particular line, that all comes down to the matter of density, that how dense that particular object is. Now, let's go to the next topic. Again, I will try to say, don't worry in these slides, just as in this slide. First of all, I know some of the people, or many of you people, have got afraid or something. Even I was once upon a time there at your place, you were getting afraid from these particular topics. But don't worry, these are really easy topics if you try to understand them via concept. Okay. So now, next, stellar evolution. Now, what is exactly stellar evolution? Now, stellar from that, stellar evolution is something, it is a cycle of a star, that how it gets converted from its original star to the black hole. And what is the exact ratio which is meant or to be exactly needed for the star to get converted into a black hole, and how it will, function its own properties before getting converted into a black hole, right? Now, let me tell you first of all, the star which you think, the star, in the first session when I was explaining you the diagram of HR diagram, Hertzsprung-Russell diagram, that was like the spectrum of stars. I told you all that in the early universes, or in the dark age of the universe, the only existing material in the universe universe was hydrogen and helium gas, right? It is a basic form of every component which you can find in the universe or even in the nebula. Okay, because that is the basic fuel for the star or even a protostar, which is a star which is just a baby star, which I say it is named as protostar, right? So the star which is having a stable core fusion, first it will be having hydrogen as a basic fuel. It will convert from hydrogen to helium, and that helium will burn under nuclear fusion reaction. Okay, now this cycle repeats for such a long amount of time that a star is there. It is having a basic life form of around million to billions billion years. Okay, now it depends what type of star it is. For example, if it is a blue star, it will end in millions of years. It is having a less age, or it is having a less living age, because the blue star which are there, it is having a pure format and they burn really fast. They burn really fast. They exhaust their fuel really fast. And a star like sun, it takes a mediocre amount of time, because our star is an average star. It takes around 5 to 10 billion years to exhaust its fuels. So our solar system is around. Okay, I will not answer this question. I want answer from you all. What is the age of our solar system? Tell me in the chat box itself, or even if you want, you can just turn on your mic. No worries. Just don't Google. Okay. So what is the age of our universe? Oh, sorry, not universe, or solar system.
4.3 billion years.
Yes, 4.3 billion years. It's correct. Great. Around 4.3 billion years ago, our particular solar system got formed, and according to the ratio, or according to the scientists, it is said that after 5 billion years, the sun will convert into red giant phase, and it will go into the this white dwarf stage, right? So this is the life cycle of a star, of an average star. And the red giants are there, or hypergiants are there. They take more time to exhaust, because the density is less. The blue star which are there, it is having more density, and they burn very really fast. So the star is having the last point. You have to understand this. This just put it in your head whenever you are trying to explain, or even if you're trying to, if you are in the middle of your friend group, you are just discussing some astronomy stuff. Remember this: that star is kind of having a onion peel structure. Onion peel. Like when you try to cut the onion, there are many layers of the onion. Just like that, star is having really many layers of elements. The period table you all have known. So like hydrogen, helium, it is having ferrous, it is having it is having magnesium, calcium. These all type of layers are there. The core is having Fe, which is there in the second last point. So as soon as the star reaches its iron layer, the death of the star gets really fast, or it is near. You can understand with this particular sentence. Okay. Now, the first sentence which is there, I will explain it in the coming slide, because you will understand it more better as soon as I will explain you one particular topic which is there, which is really very proud to explain, because it is made. It is named after a very great Indian scientist. Now, let's go ahead. So, how normal black holes come about? Now, to be honest, many scientists say that in the dark ages, when the universe was really a few very young, at a very young age, like 500,000 years old, the universe was. When there was only clouds of dust, and heating clouds were there. Stellar nurseries were about to form. So at that particular time, black holes started to form. So that is how, because of why some black holes which are so huge right now, that scientists say that if we calculate it normally, these black holes are so huge that how did they got time to get into such a big amount of matter into themselves and get so much big. So that is why many scientists predict that from the very start of the universe, the black holes were having the black hole were about to start to form. So so that is how it was predicted. And a normal black hole, which you all can see in the topic here, actually when massive stars die by a supernova, so at that time, if that particular star is having a particular limit, I'll explain that also in the next slide. A particular limit is there. After that ratio, if that star mass is exceeded from that ratio, then it will turn into a neutron star. And if even that particular ratio is surpassed, then it will turn into black hole. I'll explain. Now, supernovas, here we come. Okay. So, my favorite topic and my favorite theory how to judge the mass of a black hole, Chandrasekhar limit. It is named after Subramaniam Chandrasekhar, the great Indian scientist, and it is actually described. Let me tell you what is exactly written in the slide. Now, when a type 2 supernova, I'll not go into type 2, what is type 2, type 1a, because there are many types of supernova as well. In the next sessions, if you all are going to give majority to those particular topics, then we will take that particular topic as well, the types of supernovas and how a star is functioning in its all its life form. So okay, now if a particular star is there, right? So if that star is having a mass more than 1.4 solar masses, okay, that means it is bigger than the sun 1.4 times, then then it will directly convert into white dwarf star. Okay. Now that white dwarf star, after it is having first of all, white dwarf star is very dense. Okay, just like that, it is less than the black hole, lesser than the black hole, but still it is having a lot bigger mass as compared to any other star. Okay. Now if you compare that, white dwarf is nothing but a neutral star. It is not having any particular kind of energy. It doesn't emit particular kind of energy. Okay, so if you go near to that, you can feel some really great burst of gamma rays and different kind of spectrum of energies. But if you are like at really far away, then you will not even see. You will just see that some dot is there. Otherwise, you will not even feel that. Okay. Okay, so after this white dwarf is also having some kind of life form or some kind of age. Now you will say that protostar is there. Now star is there. After star dies in the supernova, it will convert into a white dwarf. Now what after white dwarf? It will convert into black dwarf. Black dwarf is a degenerate material of a star, which is, this is hypothetical. Okay, right now it is there. There is not any single proof of black dwarf star. Okay, black dwarf is just said by the scientists that it is a degenerate type of star which is having all the degradable materials on its surface, and it is of no use. First of all. Okay, so this is how the life form of a star goes in an overview, on a short overview, which I explained. Okay, now you all have got the basic foreword of Chandrasekhar limit, what it is, and 1.4 solar masses. You can remember this. After 1.4, the star will be converted into a white dwarf. But if this number is bigger than 3, if the number is bigger than 3 solar masses, it will directly convert into black hole. Okay. Now, this is the slide which I am explaining that what is exactly. Now the figure which you can see, it is a pulsar image. Okay, you can see that how neutron star is there in the between, and the beam of radiation which is around, which is emitted by the poles of the neutron star. It is a beam of radiation which is mostly having gamma rays, and this beam of radiation travels at a speed of 99.99% the speed of light. Okay, now 1.4 solar masses and 3 solar masses. You have got this. Okay. Now let me tell you that if neutron star, this is having, there is a particular concept which is said by the black hole, that black hole is having density, gravitational power, and angular momentum. Now, if this neutron star is having a very particular angular momentum. I think I don't remember the number, but if this angular momentum is more than 30,000 RPM, okay, or sorry, 3 lakh RPM per second, okay, 3 lakh RPM per second, you can imagine how fast that is. So if that particular speed is more than this number, then the neutron star will be converted into a pulsar. Now, what is exactly pulsar? Now, pulsar is not that bike. Okay, pulsar is something. It is a type of star which is emitting gamma ray burst at a light speed of 99% the speed of light, which I just explained a few minutes ago, right? So these are having very, very, very harmful beams. If this beam touches your body, it will just tear apart your DNA and mutate you instantaneously. Okay, so so this is a very strong force which is applied, and this is how it is actually, because of the angular momentum, these beams of light are created, to be honest. Okay, I'll explain it in a further slides that how quasars are formed. Okay, so yeah, till now, any questions or any doubts, anything you want to rectify or you want to share anything? Vishal sir, any questions have come?
I have a doubt that What exactly is a neutron star? What
Okay.
exactly it is?
Okay, now neutron star is see in the name itself there is the answer is hidden in the name itself. Neutron star is something which is having the basic material of neutron. Okay, neutron. No, no, what is exactly neutron? Neutron is basically a subatomic particle which we all have learned. Like in the center of the atom, we it is having like proton and neutron is there. In the orbit there is electron, right? So the neutron is having negligible or exactly that it is not having any particular charge, and it is combined with a proton in the atom. Now neutron star, it is mostly having, it is like majority atoms which are present on the neutron star, it is neutrons itself. So this is a basic overview that what is basically a neutron star. When that particular neutron star is having more RPM or more rotations per minute, and horrible amount of rotations per minute is there, then it will be converted into a pulsar, which I just explained that how the beams of light are emitted from the poles of the neutron star, and it emits some kind of very harsh gravitational waves. These particular gravitational waves were detected by the LIGO, LIGO, which is there. It is a particle. It is actually a gravitational wave detector, which detected the black hole gravitational waves in 2015, 17, 12, I think. Yeah. So in the late 2010s and last decade, they discovered the gravitational waves from LIGO itself, and that is how it is actually. The process is, yeah. Someone else, someone raised the hand. I saw.
Um,
Okay.
Excuse me, sir. I have a doubt.
Yeah, yeah. Please go ahead.
So actually, in terms of celestial bodies, the basic concept of difference between a planet and a star is that a star is a body of where continuously radiations takes
Your
place in
voice is
and
actually cracking.
on the
If
surface of the star.
your voice is actually cracking, I'm not able to hear you.
Am I audible?
No. If possible, can you like type it or something? It will be better. I'm not able to hear.
Sure, sir.
Vishal sir, can you hear the question?
no, I'm unable to
Okay.
hear.
Okay, okay. Sarvesh, it will be better if you type it, or even you can send it on personal, or even you can send it now as well. It will be better. I can resolve it right now itself as better as possible.
Sarvesh, can you kindly shift yourself where there's a good network? So,
Anyone else? Anyone else
So
having any
I'm
doubt or something?
typing.
yeah, yeah, you're
Yeah, yeah,
typing. Okay,
Sarvesh.
sure.
Yeah, okay, no problem. Anyone else till then having any doubt, any theoretical, conceptual, anything else you want to clear out, or any different topic, regarding black holes which you have heard or something?
Guys, this is not a classroom, okay? Just
Yeah.
here, we and you, let's share the knowledge with each other and let's grow together, okay? Be open, like if you are wrong also while asking the question, it's no issues. We are here to share the knowledge and grow together, okay?
I have one more doubt. Can I ask?
Sure, sure,
Go
please.
ahead.
Yeah, the doubt is that the black holes which are large in size have less gravity towards it, and the black holes which are small in size have more gravity or absorb more things in the space. Why is it so?
Can you repeat? Can you repeat?
The black holes which are larger in size have less gravity, but the black holes which are smaller in size compared to that larger black holes have more gravity. Why is it so?
Okay, great. This is actually a great question. This I was not expecting actually, but great. So let me explain you with a very childish example. Let me explain you like that. For example, if you are playing, if you're playing with a balloon, okay, the balloon is attached to the wall. Okay. Now, if you take one mobile, or if you take one cardboard, okay, and if you throw the cardboard on the balloon, is there any probability, is there 100% probability that the balloon will that the balloon will burst? No, right? So, and if you, at the same point, if you take a pin, or if you take a very sharp object like a scissor, and if you throw it on the balloon will burst instantaneously, right? Same way, it is just like that. Now, the black hole which is having a bit small, okay, not that small, okay, really, if the black hole is really small, it will evaporate. Okay, I will tell you what is exactly why I said evaporate this word. This is Hawking radiation concept. I will not go in that depth right now. I'll explain in the next slides. Okay, now let me get back. The thing is that if the black hole is having approximate, if it is having a mediocre mass size, and if one black hole is there which is having really very big mass, like 40 billion solar masses or something, right? So 40 billion means, I think, 4,000 crore. 4,000 crore suns should be masses is there, and at one cost it is having 10 million. Okay, so this is a very big mass difference between two these black holes. Like, one is really small, one is really big. So the smaller one which is having, which you are saying, it will be having much more impact around the space fabric time, which is nearby itself. Okay, now why is it so? Because it will be Vishal sir, can you mute your mic, please? Okay, thank you very much. Okay, so if you are just going to that, if you compare those two particular black holes and its area of vicinity, then it will be the smaller one will be having a big impact around the space fabric time around itself. Now, the same example, because it is having a thin, it is having a point, it is having a point density, and it is bending the space fabric time at a very thin and very precise or very cutty edge. That is why it is having a sharp gravitational impact around itself. The bigger one is having a blunt. No, I'm not saying it is having nothing impact, it is having, but the thing is that it is like a surpassing level would be very different, or it will be surpassable from the bigger one. If the black hole is really big, then at some point of time you have that particular power, that if you have the fuel and if you have the capability of your engine, then you can escape that particular black hole before the event horizon is there. If you go inside the event horizon, you can't come back. But if till one point, you have the power to come back. But in the smaller ones, you're not having that facility, right? I hope my explanation was vivid.
Yes, thank you.
No worries. Thank you very much. Okay, so Sarvesh, your doubt is I can read it. Don't you think that the yes, exactly. It is a very precise explanation given by you, Sarvesh. It is actually true. What you are saying, it is quite accurate. The thing is that after the supernova happens, you might know that after supernova happens, most of the material which is there inside the star, it is actually thrown out of the star, or because of the big bang which happens inside the core of the star, every material is thrown out at from every direction. Okay, it is not like a pulsar throws the direction, throws the particular integrand from the poles, but in a supernova it is just like a very big boom in the universe, and it is a very big phenomena which is happening in the space. So at that particular moment, as I said, that stars is made up of many materials, many elemental materials which are there in the periodic table. So every material is burned out now, and the material which is present, it is of no use. For example, if the remaining helium is there, remaining hydrogen is there, iron is there, calcium is there, or anything else is there, the gravity surpasses and the star collapses in itself. Gravity wins, and it happens a big boom, which is called a supernova. And every material which is present, every active material, to be honest, is whichever is present on the surface of the star or in the core of the star is thrown out, leaving nothing on the star. So neutron is actually as neutron is having nothing. Neutrons means actually it is considered negligible. It is just having mass. Neutron is just having mass. It is not having any ionic charge or any impact on the particular ingredient. So yes, that what you are saying or what you are trying to mention, it's really correct. I hope you agree to my point. Is it so? Yes, yes, yes. It is. See, you can't underestimate still. Okay, you are underestimating the neutron star now. Okay, so the thing is that if there are now neutron stars, you might have heard about the hypothetical thing that it is there is also a magnetar, there is also pulsar, there is also grava star, there is also neutron star. So these are some type of stars which are there in the present universe. Grava star is, I think, a hypothetical star till now. It is not much proof of it, but these three which I said, those are having proof and these exist in the universe. So neutron star is a very it is not dwarf till now. Okay, dwarf star is different. Dwarf star is having no energy, or to be honest, it is just rotating around the star, which is it is dependent on some other star. Now let me tell you, neutron star is having a capacity to steal the energy from its another star as well. Now if you know the binary systems which are there, binary star system, there are also some concepts which are called as ghost stars. So ghost stars are some kind of stars which steal the energy from its binary star, and it can repower itself, repower itself, or rejuvenate its energy in such a manner that it will become again star, and it will function like a normal star itself. So until and unless the pulsar or the neutron star doesn't get converted into a black dwarf star, until then I can't say that it is not a star or something. Okay, the same way which I want to say, if let me tell you, when our solar system was in the formation period, when the sun was a protostar, there was one more star with the solar system, which is now called as Jupiter. Jupiter just didn't got that particular energy or that particular material to get charged up as a star. That is why it didn't become a star. Otherwise, today our solar system would have been a binary solar system. The two stars would have been there, or two suns would have been there, but it was not possible because of the less amount of debris. So that is why now Jupiter, if you search what is the nickname of Jupiter, it will come out to be the brown dwarf star. It will come out as brown dwarf. So that is how it is like. So it is like Jupiter is not called a star, it is called as dwarf. Dwarf is something which is having no energy, nothing, but it is totally dependent, or no independent energy which is having from inside. You can't say that it is not having any energy. It is surely having some energy, because that is why it is having a very big rpm, or it is very having a very great number of angular momentum it is having. So it does having some energy. Surely the ionic stage which you are talking about, the ions, or the if you say that the proton or the electron, if you say, it is not having that, but the mass wise, density wise, it is a really a big star. Even a normal star is small in front of a neutron star, because even a spoonful of neutron star material will be more than will be having a more mass than a billion tons. Okay, billion ton I'm talking about. 1 billion is 100 crores. Okay, 100 crore tons. Okay, 1 ton is 1,000 kgs. Now multiply that number by that number, you will get something. Okay, so I hope I have clear with my explanation. Is it so? What would happen if a planet become both black hole and white hole? Okay, okay. Let me tell you this question I will remember. Vishal sir, please note this question down. I will complete the PPT and soon I will answer this particular question. It is really good question and people will be
Yes,
very much interested in this particular thing.
and we
Okay,
and
so let's get back to the topic, guys.
and we have really interesting questions in YouTube also, guys. So let Soham complete his presentation. Whatever questions you have, so you can ping it in chat box. At the end of his session, Soham will answer all your questions. Okay? Yeah. So
For
continue.
sure, for sure. Even I am getting interest interest in this answering these questions. It is really nice. Okay, so where could supermassive black hole exist? Basically, there is no particular address to supermassive black hole. It can be present anywhere. There is also a thing, there is one particular hypothetical theory that if the sun, if our sun is there, if you turn that sun into a black hole, which we discussed earlier, so chill radius, right? So if you turn our sun into a black hole having the same mass as a sun, for example, if our sun is having 100 kgs mass, okay. For example, if our black hole is also having a 100 kg mass, okay. Now, if you turn that particular sun into a black hole of the same mass, then what will happen? So, will the black hole suck every planet, or will the solar system collapse? Will the orbit will get degenerated, or will the planets leave the solar system in tangential motion? So these are some kind of very hypothetical thinking which is there, but thing is that the answer to this question is not any of this question. The answer to this question is that, or this thinking, the answer to this thinking is that nothing will happen. The Earth, the Moon, and all the planets which are there orbiting in their right now in the present orbits, they'll continue to orbit further till the black hole is either converted by the sun again or anything bad happens. Okay, the normal orbital mechanics will be followed, or normal physics will be followed. There will be no such thing that they will suck the planets or something, because the mass is same. So that is why there will be no particular disruption in the orbit or in the gravitation of the solar system. But just one difference will be there, that the light which is emitted by the sun, it won't be there. So we'll freeze to death, because the light which is we are getting, it provides heat as well. So we'll not get light, we'll not get heat. So the earth will go into an ice stage and we'll all die. So this is something hypothetical thinking, or actually to this particular story which you find very interesting. This thing is also very mathematically calculated, or having a very precise logic behind this thing. Okay, so don't just say that this is our stories or something. This is having precise logic behind all those things. Okay. Next slide. Active galactic nuclei. Now, active galactic nuclei. This sounds a very heavy word, right? So active galactic nuclei is nothing but it is something which produces more radiation than the whole galaxy combined. So, for example, if you see the if you see the picture of a galaxy, right? If you see the picture of a galaxy right now, you will see that the center of the galaxy is having a lot of light in between. That it is sparkling a lot. It is bright. It is really very bright. So these are some things which you should take into mind. That it is very bright. It is having, like, the whole galaxies is there. The galaxies, for example, Milky Way galaxy is having a diameter of 1 lakh light years. Okay, 1 lakh light year. It is a very big number. Okay, when light is taking, means if you travel with the speed of 3 into 10 to the power 8 meter per second, it will take you 3 lakh years to go from one particular point of the galaxy of our Milky Way to another point of the Milky Way itself. So 1 lakh light year, it is the diameter of the Milky Way. Now, if you see the picture of the Milky Way, in the between that whole big galaxy, you can see the center, which is very concentrated. It is having very bright in nature format. So that is nothing but the active galactic nuclei. That is something you called as active galactic nuclei. That's all. And it is having a lot of radiation is getting emitted continuously by the black hole, which is there which is located in the center of the galaxy. And continuous quasars are also getting emitted. I will explain in the next slide that what is exactly quasar. Okay, I hope you have got a basic overview that what is exactly active galactic nuclei. Quasars, one of my most favorite topic, the topic which have beguiled me since the very start of the black hole theories or paradoxes. So quasars is something, a phenomena, basically a phenomena which is having extreme electromagnetic radiation is emitted from a beam of light which is emitted by the black hole, or by the black hole which is emitting the quasar. It is due to the plasmic reactions which is happening at the accretion disk of black hole. Now, what is this? What the hell did I talk about right now? So the thing is that black hole is having component. For example, if you imagine your computer is having monitor, CPU, mouse, keyboard, everything. Same way. There are some components to black hole. Accretion disk, which is there, the disk which is there. The surrounding area of the black hole is nothing but accretion disk. Just remember like this, okay? The black format in the image, which you can see, something is revoluting continuously around the black hole. It is accretion disk. The black thing which is there of the black hole, the surface, it is called accretion disk. It is called as event horizon. As soon as you go inside that black thing, you can't come out. You will just go somewhere else or you will die. That is something. First, you will die. Sorry, due to the extreme electromagnetic radiation and due to the extreme plasmic reaction which is happening at the accretion disk itself, you will die. Then let's take an example of quasar. Now, what is exactly quasar? Quasar is nothing but the resultant of the plasmic reaction which is happening at the accretion disk and the overheating of the black hole, and it is not able to take that particular heating inside itself. That is why it emits or it it pukes out, to be honest, or to explain this particular thing in a very vivid format. It pukes out that particular plasma or that material which is having revoluting around the accretion disk or around the black hole in the format of electromagnetic radiation, gamma ray burst, and at the speed of 99.99% the speed of light again. And this is again a very harmful thing, and this is again having thousands and thousands of spectrum of light, and every kind of energy is situated inside this black hole. So this is how it is, and it is extremely luminous, extremely very bright. Okay, and this is actually happened due to the frictional bond which is there between the every body which is revoluting around the black hole. I hope you are clear about the quasar, definition of the quasar. Okay, and it is actually, you can see the first line which I have written there. Quasar is a subclass of active galactic nuclei. Okay, so you can understand that what I want to say from this. Okay, let's go to the next slide. So, how a supermassive black hole is formed? According to theories, there are three very big theories from the lumps of the early universe. What is exactly lumps? Just now I explained you that the stars which are there, the stars which are getting formed, they take the matter around itself. They take the dust, the helium, the hydrogen cloud, and all kind of things according to the gravity. For example, there is one asteroid, right? It is having some kind of gravity. As soon as it will go inside a sterile nursery, or sterile nursery means the cloud of hydrogen and helium. Okay, as soon as it will go inside the cloud of hydrogen and helium, it will get a bit energized, right? As soon as it will get energized, its gravity will increase. As soon as its gravity will increase, it will start interacting with the other asteroids, meteoroids, comets, planets around itself, and it will become a bigger planet or bigger celestial body, having a bigger solar gravitational having a bigger gravitational influence, almost double or the combined to those particular celestial bodies which are interacting with each other. So that is how we call it in astrophysical language. We call it lump. Okay, so the lumps, from those lumps the black hole can get formed. Stellar seed model. Stellar seed model is nothing but the collapse or the after the supernova which we discussed right now, it will directly convert it into the black hole. That is stellar seed model. Then whole star cluster. The whole star cluster, that means, for example, a nebula is getting the whole nebula is getting compressed into one point, and it will get into a black hole, supermassive black hole. So these are some three theories which has validation and which has some logic behind them, and that is why they are creditable and very much durable and scalable. So these are some theories how black holes are formed, and you can see the collapse of the whole cluster which you can see here, the many stars and stars which you can see. The blue format is nothing but the cloud of hydrogen and helium. The small dots which you can, every dot which you can see is a star, in the middle you can see that how big, how bright it is getting, and slowly after a few millions of years or few thousands of years afterwards, this will convert into a black hole. And this is real image. This is not some generated or simulated image. It is a real image, and you can see the name of the star cluster NGC 1850 to the right. So yeah, this is how it is, and it should be above Chandrasekhar limit. Yes, in the bracket I have written it above Chandrasekhar limit. It should be having, then only the black hole will be formed. Okay. So yes, these are some things, observations of supermassive black hole. Now, how do you observe? No one asked me this question till now. If the light can't escape the black hole, then how can you see the black hole? Whatever you see around yourself, the wall which is there around you, the laptop or the mobile which you are on right now, you can see it because the light is getting reflected from that particular thing and it is going inside your eye. That is why you can see that particular surrounding items. Okay, but if black hole is not reflecting, it is absorbing the 100% of the light. Then how you can see that black hole is there, or black hole is present at that particular end of the universe or that particular end of the galaxy? So how you can observe them? How you can observe? That is the main question. Okay. So answer to this particular question. Anyone want to say anything on this particular question which I raised right now? Anyone answer you want to give? No. Okay. No worries. Okay. So okay, someone asked me that what is the difference between big black hole and small. So I just answered it. I think because of the pinpoint or the sharp edge, or it is having a particular sharp impact on the space-time fabric. That is why small black holes are having big impact around the space-time fabric. So yeah, let's get back to the topic. Observation of the supermassive black hole probably by the radiation emitted them. Yes, that's true. That's actually the true answer. So radiation which is actually emitted, or the accretion disk which we were talking, the friction which is going on, the plasmic radiation which is carried out at that particular outside of the black hole, and concentration of every matter around the black hole, we can say that at that area or at that particular surrounding of the galaxy, black hole is present. You know. So yes, this is how you can observe that how black hole is present. Now X-ray observations can be done because plasma, it actually emits every type of spectrum. So X-ray can be observed. Optical, which is observed by Hubble telescope. Chandra Subramaniam Chandrasekhar, again this scientist, great scientist. It is this observatory or this telescope. Even the image is X-ray, or the Chandra Observatory, which is actually a joint collab between USA and ESA, European Space Agency, and NASA. This was named after Subramaniam Chandrasekhar, Indian scientist. And optical observations which are done by Hubble Space Telescope. As you can see that a visible spectrum is also emitted in all these spectrums of length. So Hubble is also one of the many great revolutionary telescopes which has helped a lot to the humankind. And Event Horizon Telescope. Now, Event Horizon Telescope is a telescope which is made by collaborating or by integrating the power of 7 different telescopes all over the earth. For example, one telescope is from USA, one telescope is from Hawaii. Okay, USA, Hawaii. One is from South America. One is from European continent. One is from African continent. One is from Australian continent. One is from Asian. Two are from Asian continents. 2 or 3 are from Asian continent. And 7 different telescopes integrated into one. And that particular power is also integrated. And then we are able to make this Event Horizon Telescope, which took the image of the black hole as well. Took the image of Messier 81 black hole, and also the image of Sagittarius A star, which is the black hole of Milky Way as well, or our galaxy. This is a picture of Hubble, and this is the picture which is captured by Hubble. Now it is a very blurry image, but it was no less than the revolution in the field of science and astrophysics. So yes, this is something. Now, what is the fate of the universe basically? Now, here comes the main topic. Actually, I haven't covered Stephen Hawking or Hawking radiation in this PPT because it will be a lot. It will be a lot of information to be put in one day. So that is why I didn't took the topic. But still, it is having a really good impact on the paradoxes of black hole. That is why I just took one slide of black hole radiation. Now, basically, I'll explain in overview format that the Hawking radiation says that if the black hole is having, if it doesn't get food, means if it doesn't get something to put inside. For example, it might be a star, it might be a galaxy, it might be a planet, or it might be any cluster of asteroids. If it doesn't put that particular celestial bodies inside it, it will evaporate. Means it will go off, it will fade away, it will lose its mass, it will lose its impact on space-time fabric, and it will vanish off. So this is how This is how, which is described theoretically, mathematically, and practically by Mr. Stephen Hawking, my personal mentor, and also by and also in the Hawking radiation, it is written there. Okay. Now evaporation time, something I've written there. Evaporation time. The universe is having a fate that he said that universe might die or might evaporate just like a black hole. It might die as soon as the right now universe is expanding. Right. As soon as the universe will become stable, or it might become stealthy. At the same time, it will start evaporating. It will start fade away. It will start to fade away, and the universe will finish it off. Okay. And the evaporation time of black hole, the evaporation time of the universe, which is there on order, it is by 1 multiplied by 10 to the power 20 years. So this is the predicted format of universe by Stephen Hawking in Hawking radiation. And the other equation which you can see, 1 into 10 to the power minus 7 m by m sun to the power of 3 years, it is the evaporation of actually a constant of a star which is compared mass to the sun. So yeah, these are some things. And this is the bibliography, like from which sites I took the credits, and from which side I took the matter and all images basically, and referring. So yes, and yes, thank you all for lending a very great ear, and it was really a very great session. Yes, I will just let me know which doubts you can convey, or let me know. Yeah, one more thing, just fill the form which is sent by Vishal sir here. As soon as you fill your form, you put your name here, your certificates will be generated and they will be sent to you on your mail, and also in PDF format, whatever is convenient for us. Either we will send it in mail, or either we will send it in WhatsApp on the group. So stay connected with us, and you will get the certificates either till today night or till tomorrow. Tomorrow morning.
Yes. And guys, so till do you have any questions till now? Or Soham, any questions have you unanswered in the chat box?
Okay, yeah. There are one or two questions which I'm seeing I haven't answered. Yes, what is the difference? No, this is not. What would happen if a planet came became both black hole and white hole? Now, this is like an impossible thing, Abhishek. Okay, this is like an impossible thing. First of all, now let me tell you why. The thing is that it is impossible because, just a second. Yeah, so it is impossible because black hole is something, it is having event horizon from where there is no point, the point from where you can't come back in the normal universe from where you entered. Okay, and the white hole is something, it is having an event horizon, it is having a point from where you can't go in. Okay, like there is only out from white hole and there is only in from black hole. So this is like how theoretically it is, it is proven. And this is actually hypothetical, more hypothetical. This is not having any practical proof of it, because the thing is that we haven't found any white hole till now in the physical universe. So that is why we can't say that this white hole exists. But logically it seems correct, and even mathematically there are some equations which say that how black hole and white hole perform, or how the black hole and white hole are interlinked, so via wormhole. So yeah, this is the answer to your question, Abhishek. Let's go to Sanjay Kumar. Motion of star around black hole, or effect causes by the black hole to the matter around it. Okay. Now, this is actually a great thing. Let me tell you, this is actually having a one word answer, but I will tell you still in a bit overview format. The one word answer is Goldilocks zone. Okay, if you are at a safe distance from the particular black hole, or even from a pulsar, then nothing will happen to you. You will just continue to revolutionize around the black hole in a normal manner, just like how the Earth does around the sun. That is fine. But as soon as you go, or as soon as you go towards the accretion disk, towards the event horizon, the time gets slower, because where the gravity is infinite, the time doesn't exist where the gravity is infinite. So at that particular time, it happens to be it happens to be the physical world which is happening, which is experienced by you right now. It will be a lot different than the universe which is there near the black hole. Okay, so time will go very slow near black hole. Inside black hole, time will not exist. And next thing is that if you try to go near the particular black hole or event horizon, spaghettification will happen. Spaghettification means any thing will become into wire format. For example, if you are a human, right? You are a human. So as soon as you go near black hole, you will be spaghettified. Means spaghetti means. Have you heard the word spaghetti? If you have heard, that's really good. Let me tell you the other word for spaghetti. It's noodles. So you will be converted into a noodle. Okay, how noodle is like, it is like a thin thread. So that the same way, or Maggie, so the thin thread, you will be converted into a thin thread. So that is called as spaghettification in scientific way. Okay, so these are just some causes, some effects which are which happens around the black hole to the matter around it, right? Can a black hole go smaller? Yes. That is the only that is the reason which is given by Sir Stephen Hawking in this particular theory of Hawking radiation, that the black hole can vaporize as well. It can go off. It can go away. Can you post a PPT in the group? Sure, no problem. After the this, I will instantly share the PPT. I'll just request you all. You can use the PPT, but just don't do the just take it or edit it too much. It will have some copyright issues. So I'll just request you not to edit it much. Otherwise, you can share it with your friends. This is not a very secret thing or something. Okay. So yeah. Next thing is, does the evaporating black hole affect on conservation of angular momentum? Okay, this is very physical question. Yes, actually, to be honest, yes. Does actually due to the angular momentum itself, that is actually, angular momentum is one of the reasons why evaporating of the black hole happens very fast. It happens very rapidly. So this is how it goes. And yeah, that is actually the reason. I hope you are satisfied with this answer. If you want, you can just text me in the person as well. Yeah.
Yes, Soham.
Yeah.
We have some of the questions from the YouTube live.
Please go ahead.
Hello, Astronautic Institute. Do you believe as a space aspirant in a multiverse concept?
Okay, multiverse concept. Yes, I do. I do believe in multiverse concept, but let
Like,
me tell
what
you
are your
all.
views? What are your views?
Okay. So let me tell you all. First of all, I am not an Avenger fan. I don't like Avenger, Marvel, DC, because it gives you half knowledge. I have seen many kids talking about quantum mechanics in a very attitude manner. So I don't like that. Half knowledge is always very harmful. So don't go for that particular thing. And yes, I do believe in multiverse concept because we don't know what the limits are. We don't know what is exactly getting controlled by the universe, what is exactly there outside our vicinity, what is exactly out our limits. We need to keep this curiosity. We can't name this curiosity by the name of God as well. We can't just say that God is there just like that. Okay, you need to have some curiosity and try to find the answer, that how is this like, why it is like 5W and 1H, why, how, when, why, and all these are some W's and H which you should ask each and every time, each and every aspect or perspective when you are trying to do research especially. Okay,
And
so don't satisfy your curiosity. And yes, I believe in multiverse from my perspective. Yes, please,
and
next question.
another interesting question. What are
Okay.
your views on aliens?
Okay. Okay. um, this is actually the in the whole seminar I didn't said but right now I'm saying it because I'm confused what to say. So actually I think that
He mean to say like,
yeah.
do you believe the aliens exist? Like,
Okay, let me tell you all that I believe in alien, but yes, I believe in alien. But let me tell you in what kind of alien I believe. I believe in unicellular life form of alien. I believe in multicellular, non-intelligent kind of aliens in, right? I believe in non-communicable type of aliens till now, okay, because we have some very good proof that unicellular life form may exist. Even an algae which is present on the other planet is also an alien, because it is not present on the Earth. It is having different DNA format. The SETI which is there, search for extraterrestrial life which is there. And to be honest, I got to meet one scientist personally from the SETI team. All you might have heard about J.N. Narayakar, right? The great scientist. He is actually a senior of Stephen Hawking, studied from Harvard University, and I got to meet him once. And he was like the leading person in the SETI. So he actually launched one weather balloon at the very high altitude of the Earth. Even they found such kind of particles, air molecules, which are not present on the Earth, or some kind of difference which is there, or the DNA formats which are there in the air, which is very different from the Earth. So even that is an alien. Okay, so you need to reiterate your definition that what is an alien and what is not an alien. Okay, if you're talking about those particular cringy life forms which are having very long legs and very big head or green color or something, so that is not the case. But yes, I won't deny that particular condition, that yes, intelligent life form do exist, because universe is so big, there is somewhere something waiting to be known. This is a quote by Carl Sagan, and I do believe in it. So yes, that is something we need to be open to all the possibilities till we get clear at any cost. Yes. Is there
And
any question?
last question: how a
Okay.
space aspirant can get the help from Astronautic Institute to pursue his or her career or dream?
Okay. If it comes to Astronautic Institute, just stay with us. Just keep an eye what we are doing, what functioning, how are we functioning, and let me tell you, after these kind of sessions which I am taking right now, after these sessions, we will keep continuing these sessions and all. But there are so many different things which are going at the back, and those all things are for you only. So we all request you to stay with us and participate as maximum as possible, because we really want to give you as much as exposure as possible. And this is basically an edtech platform. You will get a formal corporate experience, and we will not let you regret. That is my promise to you. So just be there and see yourself how you grow, okay, into such a human being that you have dreamed of. So yes, that is how I want to answer this question. Any other thing? One question was here. I will answer this last question, then we will conclude our session. What happen if the sun become a black hole and takes the equal amount of mass of the sun? We have discussed this in a very detailed format. The thing is that it's just that nothing will happen. The orbit will stay in as it is right now. Just the heat and light will not be there. So Earth will go into an ice phase, and we all will die because of the cold and minus degree temperatures. Sir, the answer of today's quiz question. Quiz question I answered, I think, right? There are two questions. There were two questions. One was the Olympus Mons question, and one was the
Sir, answer
color
of
of the sun, which is white. So yeah, that is how it goes. And let me conclude this session, guys.
last question. Sir, the answer of today's question.
Yeah, I answered that only. There two questions were there. One was
Okay.
Olympus Mons, which was with Mars, and one was color of sun. Yeah. So
Yeah.
okay.
Yeah.
With these words, I will just
Yeah.
say that stay
Um.
curious. Yes, yes,
Yeah.
please.
Yeah. 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 So, thank you for the wonderful webinar, both Soham and Vishal. So, team,
Guys,
we'll have one means continuous webinar. So, and our next webinar will be on Thursday. Okay. So, we already mentioned there itself. So, next webinar will like on Thursday on same time, and it will be on CubeSat. So, most of them in the last poll session which we saw, so most of them are interested to learn or know about CubeSat as well. So our astronomy scholar Soham will take over the next webinar. So and it will be free of cost. So you don't need to worry about those things. So for certificates and all, has Vishal is shared the thing right. Uh, Google form. Please fill that Google form now itself.
So you will get all of your certificates by maximum tomorrow afternoon through all of your mail ID. Yeah. Thank you. Yeah, Vishal and so on.
Yeah,
Continue.
and one more thing, guys. Meet Dhanush. He is a co-founder of the Laksha Aerospace startup company, which is situated in Bangalore, Karnataka. Dhanush, he meet Dhanush. Yeah. Can you send it again? So just a minute. Yes. Yes. So, guys, one once again, I have shared the Google form link. Take a screenshot, or you can copy, or like however you want to fill it, guys. And you can as soon as you fill the Google form, you will receive the certificate through your mail IDs. Okay. And once again, thank you, guys. Thank you for your cooperation, and I would like to thank Soham also for conducting a really a wonderful and mind-blowing webinar on black hole. Okay, so kindly fill the Google Forms, and like for further updates, stay tuned in the group, guys. You can leave. Everyone can leave, guys. Thank you. Thank you all.
Thank you, guys.